think there might be a projector on the way, but if not, I'll just keep talking because I can do that pretty well. Well, welcome to Anime Science. Are we all here for buying that place? Buying my totally license? Fantastic, I get lost easily. I've been here forever, but they rebuilt the whole building, so it's like, no, I'm still totally lost. It's really, really annoying. But hey, good morning, or afternoon, or yeah, it's morning somewhere. I lose track. Maybe random day. But yes, this panel is one I have set up that I've been doing for a little while now. That I like to talk about a few interesting concepts that come up in anime and in general that tend to defy a little bit of logic and just kind of discuss those a little bit. Let's see, where to begin? Well, I think one thing that kind of comes up a lot in anime and kind of gets glossed over is you have this anime character, and they've kind of established that this is, a relatively, they'll establish this hero as a relatively realistic type of setting where people don't have any superpowers, but it'll be like an action anime. With action characters, there'll be a secret agent character in it. And I'm always interested because I'll see these certain secret agent characters, especially in 80s anime, who they'll get hit by a car, straight on at 30 miles an hour, and they'll just get back up and chase after you. They'll leap 20 feet in the air, they'll punch somebody through a brick wall, and they kind of just roll with this. It's like something feels a little bit off. I'm not sure. I've tried jumping pretty high, and I'm usually on a good day I might maybe get 3 feet, I'm pretty tall, but somehow the leap to the top of that building is a little bit out of what I would call human range. So let's start with actually what is kind of peak human? What is actually human limits in terms of physical ability, in terms of physical speed, in terms of strength and whatnot? Well, it's got me, I was trying to figure this out, so I ended up looking up a lot of Olympic records, looking up little data, a lot of the little shows they do on the science of martial arts and whatnot. And kind of to get a decent gauge is that for overall human beings, what we do is we tend to run on in between to 5 to 8 kilowatts of power output, pretty much kind of constantly, and usually not physical effort. With the amount of energy that we have stored up chemically in our bodies and how much we tend to output a lot is in about this range. In terms of how fast we can run, the fastest human being kind of recorded tends to get up to close to about 28 to 30 miles an hour. In terms of a high jump, we can really do be kind of the low average, not much more than maybe 20% of our own length. Sometimes it would be more Olympic areas are 80 to a full body length. If anyone has ever watched any Tony Jaa movies, Tony Jaa is been made famous for his ridiculous jumps. He will leap and he will knee a person in the face at a downward angle because he is leaped pretty much above them and is coming down. And it's pretty impressive. There is in terms of general reaction time and speed, human beings tend to, on average, our reaction time usually is around between a third to a quarter of a second. More trained, more heightened kind of practice individuals have reaction times that can get kind of down to less than 1/10 of a second. Getting really pushing it. So that's kind of where we are there. Perception-wise, the phrase 2020, does anyone know where the phrase 2020 kind of comes from? Well, the idea behind 2020 vision is that basically the people have a standard of how much resolution. And resolution is the ability to resolve, basically be able to tell if there's a difference between two objects, between two images. The general idea is you take a line, you draw a line, draw another line, and you bring the lines closer and closer together, and the closer together they can be, you can still tell if there are two different lines, the higher resolution that you have. And the idea is the more individual pieces you can identify. And then 2020 vision is that, or 6.6 given in any other place that isn't America because everyone else uses metric. is the ability to resolve a certain amount at 20 feet, and then 29, and then you'll have variations of this, whereas like if you have like a 20/40 vision, where you instead of where more people can resolve at 40 feet, you resolve at 20 feet, so the vision is a little bit worse. And then you have the flip side, where someone can resolve at 20 feet, what other people normally can only resolve at 10. And then like 10 is really kind of the upper, as well as high as getting close to about as high as people can actually perceive and whatnot. Where in terms of how acute vision can get, you can get a little bit, like sometimes a little bit above that, but it's very, very, like rare, like genetic anomaly, X-Men kind of rare. The important thing to kind of keep in mind also about human abilities is the fact that we tend to spend a lot of time focusing on more of the kind of default faults and defects in biology that kind of can limit us. But there are lots of cases where you have the very opposite end of the spectrum, where certain genetic anomalies give people added abilities. There's probably Lance Armstrong is probably one of the most famous cases currently, given like he has a very unusual heart. Its size and the way that it pumps actually makes it more efficient than normal hearts, which is why he can ride a bike forever. Another good example of this would also be Bruce Lee. Funny phenomenon with Bruce Lee is that he shows up in movies and in martial arts tournaments, just punching through people at 1 inch away, just moving so fast that cameras and eyes cannot follow him. I mean, to this day, when I watch Enter the Dragon, he's in that first match, and he launches his first attack, I never see him move. I only see him standing, then I see him teleport about a foot forward, and then the guy that he was fighting is on the ground. That's more or less what I still see. I get a little bit, sometimes I get a little bit, I'm beginning to get a blur. My perceptions have gotten a little better, so I'm beginning to get a blur, not just the teleportation effect. Well, progress. But one of the things that happened is that after he became into the movies, that people flocked to Wing Chun Kung Fu. They flocked to Chinese martial arts in general, especially Wing Chun, because they wanted to all be like Bruce Lee. You see a similar event happen with a European wrestler who went to Japan and beat all the jiu-jitsu champions. You had these jiu-jitsu masters just flocking to Europe just to study these various grappling techniques. Gracie Jiu-Jitsu, when Royce Gracie won the first UFC, Gracie Jiu-Jitsu became this staple of mixed martial arts. Mixed martial arts are more or less now like 40% Muay Thai and Brazilian Jiu-Jitsu, 30% boxing, wrestling, 20% like karate and taekwondo, and about 10% other things, but it has this huge impact. And mainly because you see these individuals who just kind of do these amazing physical feats with these arts, and so people flock to the art, which, not necessarily bad, but is a little bit misleading in that the people kind of don't realize that there was a massive, the importance of physical prowess, that certain people have a natural potential that others don't, and that when it's trained properly and when it's trained intensively enough, it creates these Bruce Lees and Gracies and in general just unfair Captain America type superhumans. I mean, there was already a whole bunch of unfair potential there, and then just kind of refine it. So human beings do have a pretty decent range of physical abilities and can actually perform a lot of important physical feats. It's easy to kind of get misled by human ability in the sense that we tend to often look at other animals and see well, these animals are so much faster and stronger. Human beings are weak and fragile. And it's a little bit misleading because in fact, muscle-wise, tissue-wise, we're not really that much different from cows, from lions, from bulls, from any other animal. That it's only a matter of how physical structure applies these different tissues. And sadly, what this means is that no, I cannot inject myself with cat DNA and gain the ability to scale walls and leap 20 feet in the air and whatnot, not without severely altering my already very lovely physique. It's all a matter of how they're designed. One of the unique things one needs to consider about human beings is that unlike a lot of animals, we can do things like this, which doesn't seem very important until you watch a bullfight. Other animals, the reason why they have so much forward power, the reason why they can get so much speed, why they get so much force, lions, bulls, and it's because they're designed to move on 4 legs and to drive all their body weight forward with these limbs. I mean, effectively, they have twice the driving force that we do in that sense. That's why they're so powerful, and then of course they will also be larger. But the problem with that is that they do not have, once they're driving all that force forward, they do not have the same ability to redirect and to change directions as easily as we can. As a bullfighter, with the way that they simply work is that they make very, very tight turns, and the bull cannot keep up with those tight turns to skewer them with. And all they have to do is just keep turning tightly until the bull gets too tired to actually care anymore. And it's a unique feature of human beings that we are so effectively bipedal. Human beings are also very unique in that we have an amazingly wide range of physical ability comparatively. We can climb and we can swim very, very well. Maybe not, we don't climb as well as maybe as any kind of cat or a different kind of primate, but we certainly do swim a lot better than both of them do. There is also some discussion about, in terms of human evolution, about that at some point it's believed that we spend a great deal of time near the water because we have a lot of physical adaptations that only make sense if you put it that we spend a lot of time in the water. Babies, when they're first born, have the ability to swim, or any other animal, land animal, drowns. We can hold, the longest record for holding a human holding breath is 20 minutes, which is the equivalent of most aquatic mammals. Our body hair is a lot thinner. We cry and we sweat salt water. These are very, very valuable resources, so not something you really want to waste. Why? So yet, unless you happen to be surrounded by salt water for some reason, like being in it. There's partial rubbing between our fingers. Just our spines are especially flexible for a primate, for our motion. It's a lot of very unique little traits that we have that make us a lot better for moving through water than your average land mammal. But so, in terms of that, human beings are very, very capable. Watching any of the Olympics, watching any good Jackie Chan movie, you can get a good gauge of what our human body can do. In terms of what we see in anime, in terms of that, they tend, although to push it a little bit past, even when the more realistic ones. This is very, very popular in the 80s, just to kind of have a random, I can punch you through a solid concrete wall type individual. Fist of the North Star might be a really good example of this, actually, because they don't really explain why you can hit someone with a wrecking ball and they're fine. They just kind of assume this is a natural thing if you work really hard at it. I mean, this is more or less. I mean, there's a character in this who's like this little tiny child who eventually grows up and he becomes nearly as powerful as his mentor. And it's like, so this little kid eventually grows up, to be punching, wrecking balls and living. But it's more or less kind of this bit of scale difference. Kind of, you see, it's something similar happens in Watchmen, where they don't really address the fact that these characters can catch bullets and leap through the air. It's just more kind of the assumed rules of the world. They can function a little bit better than what we normally can. Now then, let's assume what might be a potential. Let's say there's a potential source for this unfair level of strength. What could it possibly be? Really, structurally, there's not really a whole lot we can do to change to make ourselves stronger. We could add a few mitochondria to our muscle cells. We can make our bone structure a little bit denser. And chimpanzees have a few different physical modifications that make them a lot stronger than human beings, but we're still very close to the same size, very close to the same physical structure. So it's a little bit of biochemical variation, but not really a whole lot. So what comes on is what if perhaps we tapped into maybe a different energy source? I mean, it ultimately comes down, our physical abilities ultimately come down to how much energy, how much power we can kind of output. So if we were able to tap into something a little extra, maybe that might be the way to go ultimately. Well, this is a very common concept, the idea of chi. This is actually not simply a concept in Eastern philosophy or in Eastern cultures, but you see it show up in South American, African, all throughout Europe, this idea that there is that there is an unseen energy that flows through the world, that flows through people, that can be channeled and directed in order to perform various feats, either from improving health, increasing strength, to healing others, and or causing some kind of harm or change to the environment. Now, it's been recently kind of discovered by a lot of concepts that are kind of been touched on by older philosophies of interconnectedness and like Eastern philosophy, are beginning to kind of show getting a little more recognition in terms of that from quantum physics. In the sense that this more study that matter on some subatomic level is all interconnected, always interacting, even over great distances. The fact that there are more layers to our reality than we actually are able to perceive. So there does kind of enter this idea of there being potentially energy in our environment that we aren't fully aware of that could be used for various purposes. There are a few examples of other forms of energy being used by animals for various purposes. For example, the electric eel is a very good example of taking a naturally occurring process in pretty much all complex living or complex animals and being able to turn to direct energy in a certain way. Electric eels, there are a lot of electric fish that usually they use the process in order to see in murky water. Like in the rivers of the Amazon and whatnot, the river system is very, very murky. Electric eels have relatively poorly developed eyes because they're really not very helpful. So they will generate an electrical field that kind of like a little radar environment around them. And depending on the conductivity of the material that they get near, will change basically the density of the image, the electrical image that they see. And they use this to navigate. A lot of fish do this. What they've also done is they've been able to take it up to a point where they can even use this to communicate, and they can also use it to stun and kill various prey. And this phenomenon was studied very, very heavily in the bee very, very early on, and it became, by studying the structure of electric eels, we got our modern battery.
Sorry, do you want to slip into the pepperoni or cheese?
I'll take pepperoni, thank you. And now I will levitate the pizza to me with my energy powers, just like in Dragon Ball Z. Yes, and yet. Yes, they are. Especially when they give me pizza. I'll have that later. Now, a big thing that's kind of been really of interest is kind of the idea of exotic matter. Getting into like different forms of energy, but recently there's a physicist who worked out the math and found out a way to actually travel faster than light, given if you were able to tap into a source of exotic matter. And it actually works out pretty much just like in Star Trek, where this of creating a gravitation, a space-time bubble. Whereas the reason, who knows why we can't travel faster than the speed of light? A couple people.
Because as you approach the speed of light, time slows down for you, so eventually your local time reaches zero.
Pretty much this is the effect that you actually experience, yes, that faster that you go, and also this also happens with more dense, something happens, is that the more the time and space get distorted, and on a mathematical principle, if you reach the speed of light, then the time is stretched out to infinity. You go past that, and so you can't really kind of flip infinity. But the actual physical reason why this actually happens is that we tend to think of space-time as a kind of a gap, a little emptiness that we all kind of just hang out in. But a more accurate way to think about it would be a kind of a different form of, almost more like a fluid that we kind of float in, that it actually has substance, it actually has It has its own kind of mass, just not the kind of mass that we are made out of. And because of that, it also has a little bit of limitations. Imagine trying to move through a swimming pool really, really quickly. You feel resistance, and like the more you kind of push against it, the more resistance you end up feeling. It's basically referred to as the electromagnetic conductance quality of space-time, but effectively, matter can only be conducted through space-time so fast before that friction and resistance build up causes space to kind of basically just push back. More or less, the reason why it takes so much energy to get particles up to close to the speed of light is because space-time is pushing back on you, and you have to like push against that resistance. It's pretty much it's quantum friction in its own really weird way. And it's one of the weird phenomena that we're dealing with, the fact that we need that space-time is not just an emptiness, it's a stuff. And if you want to do things, which is both positive and negative, because you can do things with the stuff if you know how the stuff works. But one of the ideas that's been postulated is that using a different kind of matter, an exotic form that will cause, like basically kind of an anti-gravity almost style that will cause space-time to expand and contract behind and before an object, creating a wave-like effect. And then the space and the wave itself, depending on how much you distort it, can travel. We'll be able to push an object across vast distances through space-time, but you aren't violating the rule, the whole speed of light rule, because the space is kind of moving, not so much the object in it. It's really, really weird, and quantum physics even makes my head hurt. Yes?
Well, something else to consider is that you're talking about the speed of light. Light is an electromagnetic wave, is transverse. That's the limit. The speed of light is the limit for something moving through the ether, space-time, as a transverse wave. A compression wave can move faster than that. Not orders of magnitude, but up to 3 times faster. It's the difference between a rippling wave or just a shock wave or something. So you actually can get a signal essentially through the medium faster. It's not matter.
It's more or less how you, with waves, really kind of all about how you manipulate the medium in terms of transferring energy. But it is kind of interesting kind of concept of this, that if you can tap into something like this, an exotic particle, an exotic form of energy, you can do a lot of very interesting, unique feats. This is kind of the concept behind, this is pretty much the concept behind Dragon Ball Z, behind Yu Yu Hakusho, behind any show where they form a ball of energy and throw it at somebody that blows up, or they teleport someplace, is kind of this idea of being able to channel an unknown form of energy that interacts with the world, with the environment in a unique way that allows you to perform a variety of interesting feats. Now there's typically a pretty big gap between most kind of shows with these energy powers and Dragon Ball Z. Mainly because like most of these characters, like your average fighting game character, like they usually, if they try really hard, could like annihilate a city block. But most of their impacts are relatively scaled down to be within a reasonable. If the government really wanted you dead, we have the technology to like deal with you. Whereas in Dragon Ball Z, there's really, if Goku suddenly got his Saiyan memory back and realized, oh wait, I should have been destroying this planet right now, everyone would just be screwed. That's actually the DBZ movie that I really want to see. I want that to be a thing. I want that to be so, like one day like he gets hit by something, or someone like he can take some medicine and it like repairs some random little synapse, and it's like, I remember, I am a Saiyan warrior and I am a dick and I'm going to destroy the planet. Wait, what do you mean I suddenly became the most powerful being in the universe over the course of my lost memory? Sweet. For example, like blowing up a planet. Blowing up a planet is an interesting kind of concept because you don't really kind of think about it too much until you actually get into Dragon Ball Z. It's kind of vaporizing a planet until it's like not there anymore. Well, I mean, the issues are like, it's easy to like regular things like that, blowing up the speaker, blowing up a chair, like even a building is a pretty easy, straightforward process to kind of ponder. But a planet is a little bit of a different proposition. For example, Like, if we're looking at like the actual, like let's just look at the scale of mass. The Earth is about 6.54 times 10 to the 26th kilograms in weight. By comparison, like a ton is that's 26 zeros behind it. By comparison, a ton is 3 zeros behind it. This building itself probably, I would say, this building probably got a couple thousand tons of material, a little more to actually make it. But yeah, so the Earth itself, comparatively, like an Earth-sized planet, is massive. The amount of power you would need to destroy it is also massive. In fact, it's an easy way to form a way to calculate it is it's called the gravitational energy constant. Basically, it's the amount of energy it would take to overcome the gravitational force that holds a planet together to disperse it indefinitely. This is the other kind of issue that you can really think of, is that you could shattering a planet, just really annihilating a planet is very, very challenging. But if you shattered a planet, you would obviously wipe out all of the life on the planet if you completely shattered it, but that doesn't necessarily mean the planet would actually be gone. And you have to think, the rule of gravity would still be in effect. So I can hit a planet so hard with enough power that the whole thing just blows apart. But like anything that gets thrown up in the air, all the chunks of it's going to come crashing right back into each other. So you'll still have a planet there. Blowing up a planet would be really, really annoying if you wanted it gone. Because you just blow it up and then it'd be back again. Blow it up, back again. Now, again, if your goal is to just wipe out all life on the planet, the effects of blowing up the planet and then starting back together again would be devastating. Pretty much everything rock essentially would be superheated and left molten by both the explosion and by the collapse back together. Anything that was alive on it, besides the most hardiest bacteria in a really, really lucky, relatively untouched chunk of planet, would really survive that kind of destructive impact. Although, admittedly, it'd be really hard to kill every living thing on the planet because life is really tenaciously annoying that way. But the big stuff, you could easily get the big stuff if you could, basically salad toss a planet. That's more or less what the effect you'd be having. Salad tossing being a little bit easier because you have to overcome the gravity of the planet to make it disperse indefinitely. That is a lot more power. It is like 3.2 times 10 to the 32nd joules of energy. Comparatively, I think a 1 megaton explosive, a 1 megaton bomb would be about 4 trillion joules, so only about 12 zeros behind it as opposed to 32. Of all the nuclear weapons on the planet that we have, we detonate it all at once. I mean, we could give the planet a decent sunburn, but other than that, that's about it. And then again, in terms of actual like what human beings are really capable in terms of power compared to nature, is that we have more than enough power to screw ourselves over. But the rest of the planet is probably going to be okay. Something to really keep in mind is that from the perspective of protecting the environment, is that the environment doesn't really need protecting. The Earth itself will continue to function and continue on, but in a matter of if it changes too much, it's really just going to be we who get the raw end of the deal. You have a question? Yes?
Well, there's another case, in the case of the planet's core is pretty much pure energy. You could theoretically find a way to use that against itself to reduce the amount of energy you would need to annihilate it.
Well, in itself, the heat itself is necessarily this is what holds the planet together. I mean, there is a great deal of heat stored in the Earth, and a mixture of the heat stored from the initial impact when the Earth was initially formed. A crust formed on it outside, and it acted basically like a giant styrofoam cup that kept all the heat inside of it. And that combined with very powerful radioactive elements, and it helps maintain the heat inside of the Earth's core. So it's with relatively very little leakage out. That's why onto the surface it maintains its internal temperature. The thing about the internal temperature of the Earth is how its interaction with our molten core. Since our core is magnetic and it's spinning, and it creates our magnetic field, which is really, really important to our survival.
Essential.
Yeah, I guess some might say essential. I mean, it only keeps out all of the harmful particles from the sun that can strip the Earth of all of its atmosphere and life in, relatively about a few hours, really, not that big of a deal. Their samples taken on Mars showed evidence that at one point Mars probably would have had a magnetic spinning core. And there's a theory that at some point that magnetic core stopped spinning. And that although the planet could have had a temperature very similar to Earth's, very temperate, maybe even waters and streams, but once the core stopped spinning, there was nothing to protect the planet from very, very harmful cosmic rays, and the planet just got stripped. For comparison, cosmic rays are like one of the strongest high energy particles that we are actually aware of. They actually contain the energy of a baseball thrown by a major league pitcher at 90 miles an hour, which seems like a lot. But then this is for a subatomic particle. So imagine like the DNA in your cells being hit with a baseball focused onto your DNA. That's more or less what happens when you hit with cosmic rays. And there's like a lot of them because they're subatomic particles. And they get lonely, so they always just have them in packs of a few quadrillion. But even though the core would stop spinning, the gravity that holds the planet together would not be affected in any way by that. And I don't think there really is enough energy that you could channel if you could redirect the heat energy into sort of an explosion. I'm not sure there really is enough that could actually. Don't believe there really is enough that can actually blow the planet apart in any way. But if you did cool a planet and made the core stop spinning, that would also deal with if you were dealing with just the life on the planet. And really, it seems whenever they blow up a planet, for the most part, in Dragon Ball Z, it's more or less the people that are on it that kind of get on their nerves. So there are lots of ways to end the life most of the life on a planet. Just ending a planet itself is really difficult unless you're something bigger than a planet, like a star.
I've heard somewhere that if you actually use a weather plant the size of the Earth and head on to it, you have to actually destroy the full planet. He does.
Yes.
But it's that big of a deal.
Essentially, yeah. I mean, another thing about an important aspect about size is also going back into the basic concept of strength as to why ants are often talked about as being very, very strong, being able to lift more than their body weight. And the reason for this is simply a basic matter of size. Two things. Muscles require surface area in order to actually contract and pull.